So let's get into the three. We're going to spend some time talking about the different types of joints that fall in the three different categories we just went over. So let's get into fibrous joints first, where we're going to talk about some of the features found in fibrous joints. We're also going to talk about the different classifications, the different types of fibrous joints. In this case, the suture, the syndesmosis, and the gomphosis. And we're going to talk about some examples of each of those types. So let's start off by just defining again what a fibrous joint is. We are connecting bones directly using a fibrous connective tissue. And there are the three main types. The suture, which we have already talked about a little bit because we talked about the sutures found in the skull. But we haven't talked about the other two, which is the syndesmosis and the gomphosis type fibrous joints. So if we're looking at the different types, the suture here, we have like the suture line. There's dense fibrous connective tissue that is linking those together so that we have little to no movement between them. The example of the syndesmosis joint, it would be the interosseous membrane that we see between the radius and the ulna. So we talked about that in the last chapter, but we didn't actually identify what it was made of or what it really was. It's a syndesmosis type fibrous joint. And then gomphosis, this is going to be the joint where that's going to help root teeth into the jaw, right? So we want to think gums, if that helps you remember. Gomphosis might help you remember that this has to do with the teeth. Our next one are the cartilaginous joints. So we're going to talk about some of the features there. We're going to talk about the two different categories here, which is the synchondrosis and the symphysis, and we'll talk about some examples of each as well. So with the cartilaginous joints, we're looking at bones that are united through cartilage, and that cartilage can be hyaline cartilage or it can be fibrocartilage, depending on what we're looking at. There's two main types, the synchondrosis and the symphysis. One, we've seen this word symphysis before in the last chapter when we looked at the pubic symphysis, but we didn't define what it is. So here we're going to talk about that in a little bit more detail. So let's look at the cartilaginous joint. So if we look at the epiphyseal plate, that would count as one because it's a temporary hyaline cartilage joint. This will stay this way until we are old enough where we can then turn this into the epiphyseal line, because we're no longer growing. And then the pubic symphysis, which we mentioned when we talked about the pelvis, right, is joining those two together. So it's a cartilaginous-based material that is joining these two together. But it also means that, during something like childbirth, we can kind of move a little bit. It's not completely going to snap if something were to put some pressure on it. And then the last one is a synovial joint. So synovial joints has a lot more moving parts, so we're going to get a little bit deeper into it. We're also going to talk about the different types of synovial joints, of which there are 6. So this is a bigger section when it comes to the joints. You can probably already then picture that there's probably more material for me to grab from when it comes to writing a test. We're going to talk about the basic structural features in a synovial joint, talk about any additional features or structures that are found with them, and then the 6 different types and some examples. So like I mentioned before, we talked about joints, and I mentioned that the synovial joint is probably what you're thinking when you think of a joint in your body, and that's because this is the most common type of joint we find, right? And again, this is the one that we really, in a lot of cases, associate with movement. There's a few different features to this. We have an articular capsule and the articular cartilage, the synovial membrane and synovial fluid, and then ligaments that are going to help stabilize this joint, both extrinsic, intrinsic, and intracapsular. We may have additional structures too, depending on the joint, looking at things like the meniscus and the bursa. So here is the synovial joint, right? This is just our generic one here. We're not worried about what joint this is, but we see our bones on both sides, but you notice the bones don't actually come in contact with each other, right? Rather, there's this open space, right, this cavity called the joint cavity that is filled with synovial fluid, right? Keeping that synovial fluid in its place, we have the synovial membrane. Right? We also have the articular cartilage capping each of the bones there, and then all the way around, right on both sides, right, we have the articular capsule, right? So we have kind of a bunch of layers that are keeping that fluid in place. The articular capsule on the very outside, the synovial membrane just on the inside, the bones and their articular cartilage forming on the inside of those cavities, then the cavity itself with the synovial fluid. In fact, when like you pop your joints or whatever, all you're doing is popping a bubble that is found in that synovial fluid. There's some interesting videos. I don't have them here, but there's some interesting videos where you can actually see that happening using medical imaging. If we look at like the bursae, so here we're looking at the knee. We have a lot more moving parts to this one, which makes sense considering the knee has to carry so much weight, has a very important job. But here's that bursa. In this case, the suprapatellar bursa. So suprapatellar, we think above the patella, above the kneecap, right? The prepatellar bursa, so in front of the kneecap, in front of it. The infrapatellar bursa, right, which again, below the kneecap. And then we have a few other parts too. We have some ligaments. We're going to go into the knee towards the end of this chapter, so I'm not going to get too detailed here, but we at least want to point out the different bursa that we see above, below, and on top of the kneecap here. So let's get into the different types of synovial joints we find. These are just divided up based on their shapes of the articulating surfaces and the bone for the bones that form the joint. And so we have 6 different types. We have a pivot, we have a hinge, we have a condyloid, we have a saddle, we have a plane, we have a ball and socket. The hinge and the ball and socket ones are the ones you're probably already familiar with, but the other 4 might not be so clear cut. So let's take some time and talk about all 6. So we're going to spend some time on this slide because there's no slides that come after this when it comes to talking about the types of joints. Let's start with up at the top here with the ball and socket. The ball and socket is like your hip or your shoulder. Again, we have like a cup and then a ball type shape. And so this is going to give us a lot of range of motion, right? We can move back and forward, left and right. We can rotate, right? We can rotate around an axis, rotate around a point. So the ball and socket joint really has a lot of movement. The condyloid joint, this would be like between the radius and the carpal bone. So this would be like in your wrist, right? You can kind of make almost like little figure 8s, right? It's a lot of movement, not quite as much as what we see with the ball and socket joint, not quite as free as that, but still a free amount of movement, right? You can move your wrist around in a lot of different directions, right? You can go side to side, so left to right, you can go up and down, and you can go at some various angles within that to some degree. The plane joint, if we're moving down to the lower right, we see that like between the tarsal bones, so we have a little bit of movement on a horizontal plane, and so we can move forward, backwards, left, right, but we can't move in any other directions, just that like on that flat surface or on that flat plane. We have the saddle joint. This is between like the trapezium and the first metacarpal bone, and so we get a little bit of movement, just kind of like we're rocking on a saddle. So if we think about, this would be, the example would be like in your ability to move your thumb, right? So think about how your thumb can move. You can kind of move around, you know, almost like in a circle, but you can't really go too far in certain directions. Right, so you can go up against your hand, or you can extend your thumb out like in an L shape. You can fold it in across your palm. You can kind of move it back, but you can't go back too far, right? So you have some limitations in that movement. The hinge joint is the other one you're probably already familiar with, because this one just rotates, just kind of moves out and back, out and back. So you think about like moving at the elbow, you can extend your arm out, or you can flex your arm in. You can't move your elbow, though, in a different direction. It's either moving out or it's moving in. You can't go left to right, though, right? So you're just kind of moving kind of like a hinge of a door. A door can open or it can close, but that's it. And then the last one, the pivot joint. This one, the key example is actually between the atlas and the axis, your C1 and C2 vertebra, where you can rotate around. So this is not going to help with up, down, or anything like that. It's just going to rotate around a single point, right, wherever that point is. And so your C1 and C2 vertebra are fantastic examples of a pivot joint. Take some time looking at these different types, especially if you look at the examples that are pointed out on this slide. It might even be beneficial to stand up and actually move that particular joint just to kind of get an idea of how that joint, that type of synovial joint moves, right? Because the pictures are kind of helpful, but actually doing the motion yourself can be really beneficial to understanding how these different synovial joint classes allow movement.